What if I told you the James Webb Space Telescope just spotted a black hole so old it formed when the universe was less than 4% of its current age? Astronomers found it inside a tiny galaxy, only 500 million years after the Big Bang. The problem? Black holes of that size shouldn't have existed yet, at least not according to our theories. So how did this cosmic monster grow up before the universe had even left infancy? But before we move on, I would like you for a quick favor. We are just starting out, so your support means the world to us. Please like the video and subscribe to the channel. Thank you. And now, let's dive right into the uncovering of our today's episode mystery. Imagine what the cosmos was like before it had celebrated its first billion years having been in existence. The first galaxies were fragile collections of gas and dust that were just beginning to hold themselves together with gravity. Stars were just beginning to brighten up the darkness at this point. Small star clusters, dim glimmers of light, and chaotic pieces clumping their way toward larger galaxies are some of the things that you could anticipate to be the origins of this young universe. However, in the midst of this rather primitive terrain, astronomers have just discovered something that appears to be entirely out of place: a massive black hole that is already located at the center of a relatively small galaxy, as if it had skipped forward in the timeline of the universe. According to the discovery, the galaxy has been given the designation CAPERSLRDZ9, and it is causing more questions than it is answering. The infrared vision of the James Webb Space Telescope is what makes this a feasible possibility. The Webb Space Telescope is designed to detect infrared signals, which are light that has been stretched out and shifted by the expanding cosmos as it has traveled over billions of years. This is in contrast to normal telescopes, which collect visible light. When light finally arrived at Webb's mirrors, it had been traveling for more than 13 billion years, bringing faint information about a galaxy that existed only about 500 million years after the Big Bang. This information was carried by light that had been traveling for centuries. Astronomers were able to discern the traces of quickly moving gas around the center of Kuiper's LRDZ9 with the help of its equipment. This was a clear indication that a giant black hole was attracting material at remarkable speeds. Let's look at the paradox. We know everything there is to know about the formation of black holes, and a black hole of this size just shouldn't have existed at that time. In most cases, it is believed that black holes originate from the collapse of enormous stars and begin as relatively small objects. There is a possibility that these stellar remnants weigh several times as much as our sun. Through the process of consuming gas and stars or merging with other black holes, they have the potential to gradually accumulate additional mass over the course of billions of years. However, if this is the nature of the process, then a black hole that weighs tens of millions of suns ought to require a great deal more time to develop. Nevertheless, here it is, not many billion years later as the models indicate, but barely 500 million years into the story of the universe. The estimations of its mass add another layer of complexity to the mystery. It is possible that the black hole that is at the center of Kuiper's LRDZ9 could weigh around 38 million suns at its lowest possible point. That is remarkable in and of itself for someone at such a young age. However, there are calculations that imply it could be closer to 300 million suns, which is much more difficult to explain. The fact that there is such a big amount of uncertainty illustrates how challenging these measurements are. Nonetheless, regardless of the precise quantity, the conclusion continues to be the same. It is significantly larger than what theory allows for at that time. There is a possibility that you are curious about the appearance of such a galaxy. The researchers refer to the Kuiper's LRDZ9 as a member of a group that they name the Little Red Dots. Webb's infrared surveys reveal that these galaxies are extremely faint and compact, and they emit a deep red glow. This is not because the galaxies are actually that shade of red. Rather, the red color is the result of the way in which their light has been stretched and shifted across the vast distances that exist in the universe. The view from our vantage point is that they appear to be tiny, flaming embers against the background of the vastness of space. It was a complete surprise to everyone when they discovered that this specific ember contained a fully grown black hole. The experience is similar to that of strolling through a forest in which every tree is only a few inches tall, with small sprouts just pushing above the dirt. All of a sudden, in the center of the forest, there is a gigantic oak tree that is perfectly tall and has wide branches that are already spreading out. However, despite the fact that the environment as a whole appears to indicate that such a tree should not yet exist, it is still present. The discovery of Kuiper's LRDZ9 is similar to that. It is a sudden sight of something that appears to be far more mature than its surroundings. If the Webb Space Telescope is able to discover a single black hole of this magnitude in such a young age, it naturally raises the chance that there are more. Is it possible that entire populations of massive black holes were already there in the universe before galaxies even had the opportunity to fully form? If that is the case, what does that imply for all of the buildings that we see around us in the present day? It is precisely these kinds of riddles that astronomers are now compelled to tackle. Simply looking at gorgeous pictures was not enough to uncover the mystery of Kuiper's LRDZ9, despite the fact that its discovery is truly astounding. Webb made use of infrared spectroscopy, which is a technique that analyzes the patterns that are present within the galaxy by dissecting the light that comes from it. These are the telltale fingerprints of gas flowing at extremely high speeds, which astronomers were able to identify by doing this. The force with which stuff is whipped around could only be generated by a powerful black hole. The evidence that was required to confirm the existence of the unseen monster that was hiding within the cosmos was that. However, while the fact that finding it was spectacular in and of itself, the real challenge is explaining how it happened to be there. Just being aware of its existence is just the beginning. More perplexing is the question of how a black hole of such enormous proportions could have grown to that magnitude at such an early stage in the history of the cosmos. Faced with this timeline that seems impossible, scientists are now weighing two bold paths that could explain how a black hole so massive appeared so early. Each path challenges what we thought we knew about the universe, and neither comes without problems. Still, these are the best ideas on the table right now, and both could force us to rethink how the first galaxies formed. The first explanation goes by the name direct collapse. Instead of a black hole beginning life as the death of a single star, the idea here is that whole clouds of pristine hydrogen gas, vast and heavy, untouched by earlier generations of stars, could collapse all at once into a massive black hole. No stars forming within the cloud, no gradual steps. The gas simply gives way under its own gravity and skips straight to the end state. If this happened, the black hole could form with a starting mass of 100,000 suns right out of the gate. That means it would not need billions of years to grow. It could jump the line, beginning large and then swelling even larger by feeding on whatever material surrounded it. The problem is, this isn't easy to simulate. Our models of gas dynamics and radiation in the early universe don't line up neatly with such rapid collapses. It's like proposing an entire building appearing overnight instead of being built brick by brick. The other path scientists consider is supercharged growth. In this scenario, a small black hole, perhaps born from a collapsing star, didn't wait around to slowly get fat. Instead, it devoured surrounding matter at a furious pace, far faster than models have ever suggested was possible. Normally, there's a sort of speed limit in place, the Eddington limit. It describes how the radiation released by matter falling into a black hole pushes back on the inflowing gas, creating a balance that regulates how much material can be swallowed in a given time. But if these early black holes somehow broke that limit, they could become giants astonishingly fast. Matter might have been pouring in through dense streams of gas, or perhaps chaotic environments prevented the usual radiation pressure from holding growth in check. Both of these paths force us into uncomfortable territory. Direct collapse demands that we accept a channel of black hole birth that skips the step of star formation entirely. Supercharged growth makes us revisit what we thought were hard limits on how quickly a black hole could feed. Either way, the standard picture of gradual, predictable black hole evolution doesn't hold up. And these aren't purely abstract ideas. Webb has already shown evidence that galaxies like GNZ11, another very early system, show signs of black holes consuming matter at rates above the normal limit. That pushes the second option higher up the list of possibilities. There's also a twist at the edge of speculation. Some researchers suggest primordial black holes might have formed in the earliest instance after the Big Bang, when the universe was still an uneven soup of energy and particles. In theory, regions of extreme density could have collapsed into black holes right away, before stars or galaxies had time to form at all. If that happened, some of those black holes might still be hiding in the cosmos today. It's a bold suggestion and evidence remains thin, but the idea hangs in the air whenever astronomers encounter a black hole that looks far too old or too massive for its surroundings. One important thing to remember is that these explanations aren't locked in opposition. It's possible that in some young galaxies, gas clouds collapsed directly, while in others, small black holes grew at breakneck speed. We may even need all these ideas together to account for what Webb is showing us. The key point is this: whether through direct collapse, supercharged growth, or even stranger origins, the discovery of these massive early black holes forces us to rethink the first chapters of cosmic history. They were not simply bystanders in galaxy formation, they may have been actors shaping the story. And that ties directly to why it matters for us, because understanding how these ancient giants formed changes how we explain the origins of galaxies like the Milky Way.